Alright, so in this problem, I have 3 to the power of x plus x equals 30. So the first thing I'm going to do is I'm going to subtract x on both sides. So now I have 3 to the power of x is equal to 30 minus x. Now I'm going to go ahead and divide both sides by 3 to the power of x. So now I have 1 is equal to 30 minus x over 3 to the power of x. Now I can also rewrite this as 30 minus x times 3 to the power of negative x. So now I'm going to go ahead and multiply both sides by 3 to the power of 30. So now I have 3 to the power of 30 is equal to 30 minus x times 3 to the power of negative x times 3 to the power of 30. That's going to equal 3 to the power of 30 minus x, because these two exponents simply just add with each other. Now I'm going to take e to the power of ln. So I'm going to multiply I'm going to write this as 30 minus x times e to the power of ln 3 times 30 minus x, because e and ln cancel out, so everything over here simply stays the same. So now I have 30 minus x times ln 3 times e to the power of 30 minus x times ln 3 is equal to 3 to the power of 30 times ln 3. I multiply both sides by ln 3. Now this can be written as 30 minus x times ln 3 is equal to the W-Lambert function of 3 to the power of 30 times ln 3. And what the W-Lambert function is if I take the W-Lambert function of something in the form a to the power of a times e to the power of a, this is simply equal to a. So as you can see here, I'm taking the W-Lambert function of 3 to the power of 30 times ln 3. However, this isn't the form a times e to the power of a yet, so I'm going to have to change this and make it into that form. So to do that, I'm going to change this to 30 minus x times ln 3 is equal to the W-Lambert function of 27 ln 3 times 3 to the power of 27. So I simply just took off 3 to the power of 3 from 3 to the power of 27. Now I can write this as 30 minus x times ln 3 is equal to the W-Lambert function of 27 times ln 3 times e to the power of ln 3. And now I can simplify this to 30 minus x is equal to 27, because the W-Lambert function is in the right form, so I simply this is equal to 3. So now I have a simple equation. All I have to do is subtract 30 on both sides. So I get negative x is equal to negative 3, meaning x is equal to 3. So this is my answer. Alright, so I have x to the power of 4 minus 9 is equal to 0. So to solve this, I'm going to first rewrite x to the power of 4 as x to the power of 2 times 2. So I have x to the power of 2 times 2 minus 9 I'm going to rewrite as 3 squared, which is equal to 0. Now, if I have something in the form a to the power of m times n, this is simply equal to a to the power of m to the power of n. So x to the power of 2 times 2 I can rewrite as x to the power of 2 to the power of 2. I have this minus 3 squared, which is equal to 0. Now, if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, a is equal to x squared and b is equal to 3. So I have x squared plus 3 times x squared minus 3 is equal to 0. So now this is going to give me two equations. I'm going to have x squared plus 3 is equal to 0, and I'm going to have x squared minus 3 is equal to 0. So for x squared plus 3 equals 0, all I have to do is simply subtract 3 on both sides. So then these two cancel out, and I'll have x squared is equal to negative 3. So now to solve x squared equals negative 3, I'm going to take the square root on both sides. So I have the square root of x squared is equal to the square root of negative 3. Now the square root of x squared, that's simply equal to x, and the square root of negative 3, I can rewrite as the square root of 3 times the square root of negative 1. So if you guys already didn't know, the square root of negative 1, this is equal to the imaginary number I. So now I have x is equal to the positive or negative, by the way, this is positive or negative, the square root of 3i. So these are two solutions of x. So now for x squared minus 3 equals 0, all I have to do is add 3 on both sides. So now I have x squared is equal to 3. Now if I take the square root on both sides, I have x is equal to positive or negative square root of 3. So these are my 4 solutions to this problem. Alright, so in this problem, I have 2 to the power of 1000 minus 2 to the power of 999 minus 2 to the power of 998. So, to solve this problem, I'm going to start by rewriting 2 to the power of 1000 as 2 to the power of 998 plus 2. I'm going to write 2 to the power of 999 as 2 to the power of 998 plus 1. And I'm going to keep 2 to the power of 998 as is. So now I have 2 to the power of 998 plus 2 minus 2 to the power of 998 plus 1 minus 2 to the power of 998. So all my exponents have 998 in them. Now, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So in this case, I can write 2 to the power of 998 as 2 to the power of 998 times 2 to the power of 2. Now I have 2 to the power of 998 times 2 to the power of 1, and I simply have 2 to the power of 998 at the end. Now, to simplify this, I'm going to simply factor out 2 to the power of 998 from this, because all the terms have 2 to the power of 998 in them. So now I'm going to be left with 2 squared minus 2 to the power of 1 minus 1. Now this is equal to 2 to the power of 998 times 2 squared, as we all know, is 4, minus 2 to the power of 1 is simply 2, and we are left with 1 at the end. So now 2 to the power of 998 times 4 minus 2 minus 1. So to simplify this, 4 minus 2 is simply equal to 2, 2 minus 1 is simply equal to 1, so I have 2 to the power of 998 times 1, which is simply equal to 2 to the power of 998. So this is my answer. Guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 81 to the power of x equals 27 to the power, we have 81 to the power of x minus 27 to the power of x equals 0. Now what I'm first going to do is I'm going to change 81 to 3 to the power of 4. So I'm going to replace 81 with 3 to the power of 4. So now we have 3 to the power of 4 to the power of x minus, now I'm going to change 27 to 3 to the power of 3. So now we have 3 to the power of 3 to the power of x. And this is equal to 0. Now, if we have something in the form a to the power of m to the power of n, this is actually equal to a to the power of m times n. meaning 3 to the power of 4 to the power of x. Well, this would equal 3 to the power of 4 times x, or we could also write that as 4x, minus, now we're going to do the same thing over here, 3 to the power of 3 to the power of x. This is the same thing as 3 to the power of 3 times x, which is simply just 3x. Now this is equal to 0. Now I'm actually going to add 3 to the power of 3x on both sides. So now we get 3 to the power of 4x. These two cancel out, equals 3 to the power of 3x. Now, because these two bases are the same, this also means that the exponents here are the same as well, because if we have a to the power of b equals a to the power of c, this means that b is equal to c, meaning 4x is equal to 3x. So now if I divide by 3 on both sides, I get 4 over 3x is equal to x, meaning the only value that would fit this would be 0. So x is equal to 0. And as you can see, if we plug 0 in for this equation, we get 81 to the power of 0 minus 27 to the power of 0 equals 0. And anything to the power of 0 is 1. So we get 1 minus 1, which does equal 0.